solve the following differential equation by using integrating factors. You may assume x is greater than -3. Use c as the constant. Okay, so we get this function. How do we do this? Well, here's the steps from the class notes. You first step one, you got to put the equation in the form dy dx, and then the y, then something times the y, and then stuff on the other side. So we got to do that first off. So, okay. So that means in particular, we're going to have to get this y term over there. So we're going to have x plus 3 times y prime minus y equals 6x. Okay, so now we have to have y prime alone, or dy dx, same thing. Alone can have anything in front of it. So I got to get rid of that x plus 3. So I got to divide through x plus 3. Boom, boom. So that gives us y prime alone minus. Now I'm going to separate these just for clarity. Like that equals 6x over x plus 3. Now this part here is called p of x. I'm looking at that. So that was step number one. All that was step number one in, putting the equation in this form. Dy dx is alone, and then whatever's next to y is called p of x, and then there's f of x on the other side. So there's that. That's why that's p of x. Now that we have it in the right form. Now, step two, find the integrating factor, mu of x, which is the integral, e to the integral of p of x dx. So we got to do that. So step two, mu equals e to the integral p of x dx, which is e to the integral. What's p of x? Well, it's right there. It's a minus 1 over x plus 3 dx. Okay. Now, what's that? How do we integrate that? Well, let's just put that minus in the front. He's not an issue. What's that integral then? That's the natural log of x plus 3. Right? Because if you take the root of the natural log, it's 1 over the argument. And that minus is just sitting in the front. Now, what can we do with that? This is really, by the way, a minus. We can think of it as a minus 1. And then that can go up and become the power. Do you remember that property of logs? That when you have a number multiplying the front of the log, it can shift and become the power of the argument. Now, why would I want to do that trick? Because then e and natural log cancel. Now that they're right up against each other and there's not a minus 1 between them or anything, when they're right up against each other, they cancel their opposites. So this will just equal x plus 3 to the minus 1. So mu is x plus 3 to the minus 1. Okay, that's step two. Step three is multiply the differential equation by that mu. First, second, third terms, all by mu. Okay, let's do that. So step three. So I'm going to bring down. Here's the differential equation when we got stuff alone. Let's bring that on down here. So we're going to say, okay, y prime, let's see if I got it there, minus 1 over x plus 3y equals 6x over x plus 3. Okay, and I'm going to multiply all these by x plus 3 to the minus 1. In fact, you know what? Actually, having said that, let's just write that as 1 over x plus 3. That'll be easier. Right? That's equal to 1 over x plus 3, right? -1 power. So let's multiply by, well, let's do it carefully here. 1 over x plus 3 times 1 over 3 times So you multiply through by that mu integrating factor. And so what do you get then? Well, this is going to be, I'll just write it as y prime over x plus 3 minus y over x plus 3 squared, right? If this y is over 1, he goes to the top, and then we have x plus 3 times x plus 3 squared equal, what happens is, we'll just multiply straight. 6x times 1 is 6x over x plus 3 squared. Okay, so there's step 3. Step 4 says the left side is the derivative of the product of that integrating factor mu of x and y. And you write it like d dx of those two things multiplied. Okay. So that's step 4 now. So that left side becomes d dx of what? Two things, of y and the integrating factor. This was the integrating factor that we multiplied everything by. The right side hasn't changed. Okay, to there. Now, by the way, you can double check that it's actually true what they're saying. If I was to take the derivative of this, it would go back to these two things. How do you know? Well, this is two things multiplied, be the product rule. Derivative of the first one would be y prime times the second one unchanged. That put it at the bottom like that. Plus, then the first one unchanged times the derivative of the second. Now, what's the root of that? Well, that's really x plus 3 to the minus 1. So it'd come down, be minus. There's the minus. And then subtract 1 would be minus 2 power, be 2 in the bottom. That's right. Okay, great. That's a little trick. And now step 5, integrate both sides. Why we wanted to write the d dx here is because now in step number 5, we're going to integrate and integrate both sides of this thing. The d dx, getting a little sloppy here, d dx of y, that was 1 over x plus 3. And this is 6x x plus 3 squared dx. I should have, whenever you do an integral, it has a dx operator at the back. Same thing here, dx. Anyway, notice what happens here. Do you see it? The integral and the d dx, derivative integral, they're opposites. They cancel. And so we just get the y times 1 over x plus 3 to drop down. That's why we wrote it as d dx of this, because then when we integrate it, it'll just cancel out and it'll be easy. The right side, though, we got to do the integral. There's no canceling here. Here the integral and the derivative cancel. Here we just have an integral. Nothing's going to cancel. So I have to actually do the integral. How do you do that? How am I going to do that integral right there? Yeah, that one's not simple. We're going to need to do a little bit of a u sub. I'm going to let u be the bottom, x plus 3. So this right here, that's going to become u. And then du is going to be dx. So this is going to become the integral of, now what do I do with 6x up there? Well, if you jump this over, u minus 3 is x. And let's just put the 6 in the front. Put the 6 in the front, and then we just have x on the top, which x is u minus 3 over, and what's the bottom? X plus 3 squared, that's u squared. Okay, and then the dx is du. Look at that. Now, is that going to really work well? Yeah, because now we can separate these. We can go u over u squared minus 3 over u squared du. And then we can say, okay, that's the integral of 1 over u minus 3 u to the minus 2 du. You seeing it? And now this, what's the integral 1 over u? Natural log of u. All right, here, I'll keep the 6 in the front. Minus, and what's the integral of this part? We can just add 1 to the power. That'll be u to the minus 1. And then divide by that minus 1, right? Well, here, I should have done it this way. Add 1 to the power, that's minus 1, and then divide by the minus 1 right there. And minus 3 over minus 1 will be plus 3, you see. All right, we are getting close. So now what are we going to do? We are going to put back in the u. What was the u? The u way back here was x plus 3. So this is going to become natural log of x plus 3 over x plus 3, right? U to the minus 1, u goes to the bottom, use x plus 3. That good? Now I have lost the left side. Let's bring it on down. It's y over x plus 3. I'm just going to write it that way. All right. Oh, and I forgot the plus a constant, right? When we integrate both sides, I should have had plus a constant out here the whole time. Plus a constant, plus a constant. All right, last step. Whew. Multiply by x plus 3 over 1. Multiply by x plus 3. Multiply by x plus 3. Cancels out. Y equals. What's going to happen? I'm going to let this 6 and x plus 3 go there. So that'll just be 6. X plus 3, natural log, x plus 3 plus. And then when 6 hits 3, that's going to be 18. And the x plus 3 will cancel the x plus 3. So it's just 18 plus c x plus 3. Wow. That's quite a bit of work, isn't it? Let's go check if it's right. 6x plus 3, natural log x plus 3. Let's see. 6x plus 3, natural log x plus 3 plus 18 plus cx plus 3. That's beautiful, isn't it? We got it. We had a lot of work to do there on those integrals. And so there we go.